Really?
Now I can see you.
Oh, hey,
What's going on, dude?
you got a backdrop now.
I know, man. I was sitting on an old rock, literally like I think it was my grandmother's mother's rocking chair. This old wooden thing, and I was sitting on for the first 49 episodes, and I was like, finally, I was like, what am I doing? So I went and got a chair, and I was like, while I'm at it, and so I got a microphone, I flipped the desk around, got a backdrop, had some lighting, and I was like, get with the times, man. So yeah, um, this is the first episode that I'm using an actual microphone, so we'll see how
I
that.
can tell the audio is great.
Oh, really? Awesome. That means okay. That means it's gonna come through perfect. Awesome. I'm excited about that. So yeah, it's 5:15 this time. Let's I know you got stuff to do, so we'll call it at 6. And welcome to Robcast. The floor is yours. For everyone that doesn't know Rob works for NASA and he 3D prints rockets. He's a mad scientist. And today, screw it, Rob, introduce yourself.
Okay, last time I was on, talked more about like my home projects, but you had said you wanted to kind of scratch the surface more on like a lot of people don't know what like the current NASA program is, what its goals are, and stuff like that.
Mm-hmm.
So I was going to focus on that mainly. One thing for sure I should mention is any opinion I give is not the opinion of the agency.
Yep.
That's just your standard disclaimer, or any conclusion that I draw is not necessarily a public like that's not necessarily the real explanation. That's an opinion more.
Yes.
So most things I say are going to be an opinion for the most part.
Okay.
Even statements about like the whole mission, because stuff like that changes and stuff, and it's always an evolving process.
Yeah.
So I sent you the video.
Watched it several times.
I assume you watched it
several times
because you commented on it. So the current program is called Artemis at NASA. So I work in the ground support. In ground support, we handle all the stuff related to setting up the rocket, getting any payloads. There may be like an additional payload, like a lunar lander, anything like that, getting that ready to go and set up on whatever vehicle it's going to go up on. Because the cool thing about Artemis versus like any other NASA program is it isn't just us. There's a new frontier kind of. So the commercial and public market kind of get to work together to push forward exploration. So one of the things that we at NASA and the exploration ground systems, by extension, kind of get laid into online a lot is cost and all sorts of things, because it is a government program.
Mm-hmm.
Our rocket is the Space Launch System. It's a big orange rocket, kind of shuttle derived, uses a lot of updated, upgraded, and evolved hardware. A lot of people say it's like recycled, but at this point, none of it's really the same anymore as it used to be.
Mm-hmm.
So on the surface, if you were to look at it, you would see, orange tank, solid boosters on the side, looks pretty normal. But in reality, there's a lot of under the hood upgrades, like the material of the tank in the middle is stronger than it was during shuttle. It's way taller.
Yeah. It's huge.
The assembly building. Yeah, it is huge. And that's one thing, like the people who worked on shuttle, which it's a wide rocket, but it's not very tall, and it's still pretty large. They occasionally get to go see some of the actual flight hardware or the training aids or whatever, or the buildings that things are even being built in, and they're like, wow, this is really big.
Yeah, so, it's ridiculous.
Yeah, it's enormous. It's one of those things that even like working on it, like when we get to see something like drive up or whatever, it gives you a new respect for how big it actually is. So The core stage, which is the orange part in the middle, is 28 feet, just about around. It's like 8.4 meters in diameter, and then it's 212 feet long. So it's almost a whole football field long, and it's just one piece. And that combined with the boosters, and the boosters are almost as tall as that, so they're bigger than shuttle. Which again, if you're just looking at a picture of it, you go, oh, okay, well that looks like the space shuttle.
Mhm.
But in reality, it's stretched, it's more powerful, it's bigger, and it has a totally different mission, and a different mission than a lot of the other launch vehicles out there. So, like I said, it's a commercial and public partnership. So SLS is one part of it, and then there's the commercial part.
Mhm.
And when you get like multiple agencies kind of working together, you can have more frequent launches. So
All right.
if we rewind, back to Apollo, you have one rocket basically. So everybody going to the moon essentially, and all hardware going to the moon during that time frame was going on a Saturn V.
Mhm.
So everything had to go in one go, one launch. You couldn't get anything there ahead of time. You had to go with everything you needed, and then when you leave, you take everything with you basically that you can, and you leave anything you don't need behind.
Mhm.
So there, you can already see it's a camping trip.
Yes.
So the whole idea of Artemis is Artemis is the sister of Apollo, like in Greek mythology.
Yeah.
So and the goddess of the moon. So the whole theme is going to the moon and staying. So setting up a long-term presence on another celestial body, and the moon's really close. It only takes 3 days to get there, and it is, because it's so close, you can communicate quickly. There's frequent windows to be able to go there, where with like Mars or Venus, you're on an annual or every 2 years pace. But with the moon, you can go basically once a month. So we have, like I said, the SLS. Then we have commercial partners who can help launch other parts. And where that comes in and staying is we can put resources up there ahead of time.
Yeah.
So
that's what the video said was. Sorry to interrupt. Can you hear that? My laptop fan's going haywire. Can you hear that?
yeah,
As long as you can't hear it, it's fine, because that means it won't come up on the. Yeah. No. Yeah. It's going. I was just thinking. I was like, "The hell is that?" Yeah. No. The video said that's what. It definitely seemed a lot more. It's almost, the analogy I could use is it's almost a little more like Air Force One. Like Air Force One brings a lot with it. It's tailed by two C5 Galaxies that have the motorcade in it. But ahead of Air Force One, hours, days, and even weeks are the Secret Service or different military detachments. It's a lot of it is already there. Like it's all ready for it, and that's what the NASA video is saying about the SLS is like. A lot of the stuff is going to be like there, almost like turnkey. Like we just got to get the humans there, like vehicles, experiments.
Yeah.
It's going to have the orbiting station.
So, So that's a good segue into it. The SLS can do crew, and that's like its one of its big strong suits is it's crew rated. So to pass the I guess the standard, you could say, to fly people on something, you need to be able to certify that it's safe enough to fly people. So it's like if something breaks, there has to be a certain number of other things that can continue working to resume the mission or maintain the mission. And like as like priority, there's like loss of mission. I think there's like loss of vehicle, and then there's loss of crew, like for severity. Most systems are made to fault and still maintain the mission, but that in the end, the idea is that's supposed to be a decision, not your force.
Yeah.
So like Apollo 13, what you run into with that is they have everything in one basket. They get to the moon. they have an issue, there is no fix for any of that,
Yeah.
you know? But in an Artemis type situation, you could foresee that they may be able to fix that scenario and stop and be resupplied. Because there are more launch providers, there are more people who are capable of sending resources and everything.
Mm-hmm.
So if you were going to go on like a camping trip or something, you have kind of two options. There's like the glamping side where you go to a campground and let's say there's an electrical outlet there for you, and that's it. You know, if
Yeah.
there's just an electrical outlet and maybe a grill stuck in the ground,
Mm-hmm.
that's a way nicer experience than going to just the middle of the woods, basically.
Yeah.
Like
Yeah.
it's a way cleaner and easier thing to do.
Yeah.
And just having those few things makes it that much easier.
Yeah.
So you can imagine if you're going to a place where you literally have nowhere to stay except the thing you arrive in and you cannot go out of it.
Yeah.
then
Okay.
Having that extra space and resources and everything really extends what you can do. So what we're going to have coming up, so Artemis right now, the like kind of short-term goal is to get people on the surface in 2024. Ahead of that, you got to get everything ready. So if we want them to go, we want it to be meaningful. You know, we want them to get there and be able to do a lot because it's expensive to put resources up there. So as a part of that, if you can put things up there ahead of time, you can extend their stay. So the first thing that's going to go up is called the power and propulsion element. And this is the first piece of the Deep Space Gateway, which is our space station around the moon.
Such a cool name.
I know, right?
That's so badass.
Like science fiction style stuff.
Yeah,
but,
Deep Space Gateway.
It gets even crazier because it's the power and propulsion type element of a new type of crewed spacecraft. It's like a drive section, a power bank, and everything that needs to support the rest of the spacecraft. It's almost like if you're going to build something, you can build it modular. So if you upgrade, you can change it out or whatever. So by building this thing, they can supply any future modules is the idea with one big module, which also has an engine set on it. So it has a series of ion engines so they're electric engines that they use a xenon fuel.
Yeah, xenon ion thruster. Yeah.
They energize it and they shoot it out the back at relativistic speeds, like near light speed. Basically.
Yeah.
And it's not a lot of thrust,
but they can forever
for weeks.
That's just for anyone listening. That's one cool thing about ion thrusters is it's not a lot. It's the equivalent of almost like, maybe this is a different kind of engine. It's almost the equivalent of like putting your hand on a table, like that downward force. But instead of firing for 10 minutes or 5 minutes, it can fire for weeks and months. And because you're in space, any change to, any acceleration, you don't lose that. So if you can just do a little bit, it goes. Sorry, I keep interrupting you. Sorry.
Oh, no, it's fine. It's fine. So it just allows you to keep accelerating, and that like in the moon environment, because it's a little more variable. It's hard to maintain certain orbits around the moon. So when Apollo went, it was in a very low orbit, and because it's so low to the ground, the moon's really lumpy, and it makes that unstable. So if they wanted to stay going around for weeks or months, then they would eventually have to do engine burns to correct that. So having ion thrusters means they can be kind of constantly fine-tuning it a little bit, and it gives them more lifespan there. Because you're more fuel efficient, you don't wear out the engine as much because it's made to run for months. And that propulsion element means that if they have a point of interest and there's like a landing scheduled to go somewhere, they can correct the gateway orbit to pass closer or whatever ahead of it, and they can kind of recon areas.
Oh, damn.
Yeah, so in the video, it kind of shows this too, where Apollo went around, I don't have a globe sadly, but Apollo went around the moon more like this,
Mm-hmm.
and A is going to go over it, like over the top and bottom.
Okay.
And it does this because as the moon is turning underneath, as you go around like this, you kind of stay stationary like this, and the moon's twisting, so you can cover the entire surface.
Oh. Okay.
Yeah.
Okay.
So every time you go around, you can imagine it like tweaks a little bit, and then it just keeps doing that until you go all the way around.
I'm listening. Sorry, I'm plugging this in.
Oh.
Sorry, keep talking. I'm plugging it in my laptop.
Yeah.
Going over the moon instead of around it.
Yeah, with that extra coverage, you can go more places. And one really big, interesting place is the South Pole, because there's known presence of water, which you can use to make oxygen. You can grow plants. You can make rocket fuel. So it is a really valuable resource.
Yeah.
So there's a lot of interest in being able to go and study the surface there, and having a station that you can go and you can meet up with, and from there you can go down and then back up and then leave and then bring more stuff for next time is really, really valuable. So
yeah.
2022, you've got power and propulsion basically arriving. Then you have a logistics module, which is like a docking port hub, and it has like a little bit of living space. Then on top of that, you get an Orion crewed spacecraft will come in basically that year, and it'll dock with it, and you'll have the gateway with crew on board able to check it out and make sure that everything's working.
Holy cow.
Science experiments around the moon. And again, Apollo is like camping trip. You're there for like a week. This is a month.
That's crazy.
So these astronauts are going up there. They're doing all sorts of stuff. They have next generation communications cameras. It's going to be really, really exciting to see like 1080p videos going around in like a live stream.
Yeah. Yeah, I can't. The video is going to be insane.
Yeah, and a big part of a lot of the stuff is like outreach opportunities. So like being able to talk to people on the ground, being able to take experiments from universities and stuff.
Yeah.
All of that's a part of it. So the first SLS mission that we're working on right now should fly in the next couple of years, and is the first test flight of the entire thing. So it's never flown before. It's brand new. Everybody wants to go real slow and make sure everything works on the first try. For contrast, though, even though we haven't been flying as much, there's kind of a new doctrine within NASA of like test until you reach a really, really high degree of confidence in the system.
Yeah.
As opposed to flying it, seeing if it works, and then improving it.
Yeah.
So happened, but there's a lot more emphasis on that first try, making it go right. Because there's a lot of eyes on us and everything, and everyone wants to make sure we succeed, because then they feel like we wasted our time and money. So we go pretty slow, but we still make a lot of incremental progress. And where one division is going slow, so right now, most of the first SLS rocket is done. The core is completed. It's in testing. It's going to be fired for 8.5 minutes of engine burn later this year, which is going to be amazing, because it's the largest rocket fired in a very long time.
It's going to be insane. Yeah.
Then our boosters are arriving later in summer, basically. So pending weather and stuff, which they kind of keep an eye on that, and they move them depending on when the weather's good and stuff. So if there's like a hurricane coming in, you don't want to have it training outside. With, but those are built and done and ready to ship, basically.
They're finished?
On top of that, we have an Orion spacecraft that is being tested.
in Ohio, and it's coming back. It's done. It's just, they make sure it's all good. So they put it in a vacuum chamber. They cook it like it's in the sun for all day, and then they chill it down to space temperatures and everything. And they do back and forth, making sure it's all working. So it's there now, and it's kind of in the middle towards the end of its testing. So it's coming back pretty soon. Then we also have our upper stage, which is already at KSC now, and an adapter piece that goes between the upper stage and the Orion. So all of the parts basically are there. It's just a matter of them together and making sure we have everything tested up and ready to go.
Dude, we're going in a space race 2.0.
Yeah, and on top of that, the second one of each and every single one of those parts is in production. So the second core stage is like making really good progress on completion. The engines for it are already ready. The boosters, I think they had a recent press release where they cast some of the last of them, the propellant for them. So they're pretty far along. It's pretty amazing, like the progress that goes on. It's just that until recently, we haven't had as much like really good presence online and in the media. And with the new administrator, a lot of that started to change, where he's seen a lot of the value. Like SpaceX plays a great social media. Because they're so known, and NASA was not playing that game. And in reality, the hardware is not that much different. The capabilities are pretty different, but the presence online was just so one-sided for a while that it
absolutely is.
Nobody knew all this great work's going.
Yeah, that's definitely one thing that not only does, and not promoting SpaceX and not putting NASA down. That's just one thing that SpaceX just like, not only do they have a presence, they have like, not even among space companies, like just in general, they have a fantastic presence. And the NASA SLS, I was like, when I started looking up stuff about this, probably in like November, December, I was like, what the hell is this? Like, wait, what is, I was like, this isn't, I thought it was like a clickbait thumbnail when I first saw it, like last Thanksgiving. I was like, that's not real. But and like, I'm online all day, every day, and I hadn't heard of it. That's that's definitely something that I want to see NASA do more of. If I file my complaint as a citizen.
Yeah, well, and that was my complaint too. And we have surveys and stuff, and one of mine was, we need a better presence. You know, we need like all this stuff, and now it's like, it's kind of a whole new game on it, where like all the bus tour that you go on at Kennedy for the public to go see all the facilities, they have one where they talk about all the people, and it's cool because I can ride the bus like with like friends or family because they want to come visit the Space Center, and I see my coworkers on the video, on the bus, where they're talking about what they do and how the whole system works and stuff. And it's great. I mean, like just yesterday, if you know who Lindsay Sterling is, the violinist, she's like really big, I guess, in like in the violin world. But like her music, a lot of younger people really like. So she ended up doing a music video on top of the Launch Control Center.
That's crazy.
A month or so ago, and they just finished like producing all the video for it and everything. And it's the piece of music she wrote is themed to our program, Artemis, and that's what the album is called.
That's awesome. So, that's awesome.
It's really cool because now all that extra stuff is kind of coming in, and we have a lot more like social media type events where we invite the public in, where you don't need a credential, you don't need anything special. So there's one coming up in Ohio when the Orion spacecraft goes to roll out that anyone can apply to, and you just come in. They have a badge for you, and you can put it on, and the administrator will be there, and he'll be talking through. They'll be given like small tours of the area and stuff of the facility, and be able to see actual spacecraft there too, right below the ships.
Yeah. You guys need to get like a meme department, because like on Reddit there's like SpaceX, and like that's, you know, our SpaceX, that's all right, but SpaceX Master Race is hilarious, and
Oh yeah.
I would have no doubt in my mind that SpaceX has a hand in that. It's just unofficially, because, you know, you can't. I wouldn't openly sponsor SpaceX Master Race, but like, yeah, like that's what NASA needs, man. You need like an off the books or like third party contractor. Get a meme division, dude. Get a meme division. You gotta go, dude. Memes are. The CIA did a research paper on the power of on the value of having a memetic division, because it's like, it's because they talked about how it moves similar to a it's like a cyber virus in terms of its ability to jump platforms and to easily convey a message, whatever it may be. It's yeah.
I can say, like, one of my coworkers and I, we make stuff sometimes all the time to kind of joke on each other, like some of the different like Orange County Choppers meme where it's them yelling at each other. And it's like
you
meetings or stuff.
Yeah.
Like really like high meta
stuff. Yeah.
Well, I have to take a picture and send it to you, because we both have like a file cabinet, and our thing has like evolved from just like making one real quick, sketching it up, and then sending it over, you know, like a quick 5-minuter, to instead of emailing it or whatever, just cutting it out of paper, like printing it, cutting it out of paper, and then sticking it, you know, so it lasts longer.
Yeah.
And it's like a trophy wall of all the things we've run into, and you know, there's bureaucracy in any organization, so there's plenty of things to joke about.
You guys need a memetic division, because not only does SpaceX have a strong presence, they consistently rail on NASA, and there's no one punching back. Like,
exactly,
at the very least, you got to go back and throw a couple mean right hooks or something, because right now they're hitting and there's no one even hitting back.
Yeah, well, and they're not allowed to, is part of it. Like,
well, that's why it's got to be off the books.
Yeah. So, funny thing, I actually, because I'll give tours and stuff sometimes, and you'll get like, university people in and stuff, and they'll come into the building, and I'll be talking about like, this is all we're doing. Outside, you know, we have all these platforms. You know, explain the rocket, because again, most people, you know, that's the orange rocket. Rocket bad.
Yeah. Orange rocket bad. Orange rocket bad.
Yeah. So, I think those are opportunities to really like be like, so this is what it actually does.
Yeah.
You know, this is the actual plan. Those, I find, those are what win people over. So I've had someone I gave a tour approach me afterwards and ask, is that all like really what's going on? Is there any more? And I like in the couple minutes I might have like to chat with them or whatever at the end of the tour, I'd like explain what I can and everything, and they go, you know, I wasn't as much of a fan of the program initially, and they'll have a change of heart, and they'll be like, I think it's really cool what you guys are doing. It's like, it's great to get that turn once you just have some time to talk about it, and it's not it's not about, you know, an us versus them, and the program isn't even about an us versus them. I mean, you got Falcon Heavy flying, you know, like the power and propulsion module. You got probably Atlas V from ULA flying the logistics module. You got a Blue Origin launched lander with I don't know, ULA launched upper stage, and SpaceX launched other parts, you know, to all link up with it. SpaceX could be launching communication satellites to help the mission, all sorts of things where everybody's flying different things, and then you have NASA bringing the crew and maybe extra cargo or extra equipment that they're laying out.
That's pretty.
Our
That's pretty cool.
yeah. So our like short term to 2024 path involves trying to look at using the surface for resources.
Mm-hmm.
So one of those missions is called Viper, which is a rover that's about the size of a golf cart, and it's going to go around. It's going to look for water on the ground. So we've looked at it from the air, but we've never actually like sampled it, seen how deep it goes. Like is it just a sheet of ice, or is it like this is an iceberg that you're on top of, or an ice shelf?
Yeah.
So Viper is going to go onto the surface, drive around, do a lot of sampling, and then I can tell you, hey, don't land here. It's not worth it.
Yeah.
Land here.
Yeah.
I think Viper is supposed to fly in like 22, 23, but that gives it plenty of time to go in and find prospective landing sites too. And the cool thing about that is because you have longer stay time, you can use your crew to do more things on the surface. So one of the lander requirements, if I remember right, is multiple days on the surface. So you're not talking like a short Apollo stay. You're talking like, a week on the ground.
Yeah.
Doing whatever you need to do, exploring all sorts of areas, and then flying back up, and then meeting with the gateway. And then you don't have to go home. You're there for another 3 weeks so that you can analyze the results that you found.
That's insane.
Yeah.
That's insane.
And there's like phases of the whole mission. So there's like phase 1, phase 2, phase 3. Phase 1 is what we're doing 2024 of, you got Viper on the ground searching for resources. You have a few other small missions. There's a commercial payload sector where they want to have small class landers where you're landing like a rover the size of a microwave onto the surface.
All right.
Using smaller rockets, like a Falcon 9, Electron even, all sorts of low weight payloads that you can maybe do a lot of like targeted science for cheaper. Like I want to go right there.
Like CubeSats almost, but like with rovers.
Yeah. One of the rovers I think is about this wide.
Yeah.
So if you imagine like a Blu-ray player with wheels, that's basically what your scale is on that.
Yeah, and I feel like that's probably the better approach. Instead of sending one, when you're shooting to Mars, it's a lot more like the original Apollo. It's like you got to have everything.
Yeah.
And that I get like the Mars, like I get the ones that are the size of like Volkswagens. Like you kind of need all that. But for the moon, I feel like that would make sense. Yeah, targeted, surgical, and not, relatively, just shoot them up and almost like a shotgun blast. Like generally spray that area with some CubeSats, little rovers, like.
Yeah. So I'm gonna. You said something really cool there, and I'm gonna circle back to it. But the cool part is because you can target a lot of areas. You can figure out things faster. And saying like Apollo versus Apollo, where you have to send it all in one go, and it being more expensive to do that. It is a lot more expensive to do Apollo, and when you if you convert the 1960s dollars, to US dollars now, you end up with like the SLS program alone, not like Artemis as a whole, where we're like, we want to develop that and that and that and do all these things. You end up with one SLS is 1/7 of a Saturn V.
Jesus.
So for every Saturn, you can send 7 SLS
Jesus.
rockets, basically.
Well, that's insane.
We get, we get back on costs.
Yeah.
And then, Apollo was over there with all the money ever.
Apollo literally was like blank check, like beat the Soviets. Yeah. Apollo, that was an unusual, because that was. Yeah, that was literally, we have to show we're superior. Yeah, we got beat by Sputnik, and it was like, it can't happen again.
Yeah.
That was different. That was almost like post 9/11 military funding. That was like, get to the moon by the end of the decade. Here's a check. John F. Kennedy. Peace. Like, yeah.
And that's kind of the problem with Apollo 2 is it only really had one goal.
Yeah.
So
Get there,
the
come
funding
back.
goes way up. They reach their first landing, and then the funding just falls off. With Artemis, there's like a forward plan. You know, you have we want people on the ground. Once they're on the ground, they're going to be doing in situ resource science. So like phase one, like I was saying, you go, you set up this basic gateway station where you have power, you got small living quarters, you have a lander, and you can do some small experiments. Then eventually, which they've kind of teased diagrams of this in and out, like what the phasing is going to be like. But then eventually you have, you know, more living space, obviously, so you can stay longer. You get more logistics modules, so you can have more like food arriving, science experiments, extra things, propellant for that propulsion stage, so you can keep it operating. All sorts of stuff like that.
Yeah.
It basically becomes Kerbal Space Program, where you're like, I'm gonna supply what I have now and keep it running and build on it.
Yeah.
And if you have that infrastructure in place, every time you come back, it's better. You know, so you can live there longer. So you could foreseeably see like mission extension. You know, instead of 30 days, why don't we go for 60? You know, a normal space station like cruise is I think like 6 months.
Yeah.
It's about, depending on the person. Sometimes they'll do a year.
Yeah.
You could foresee a gateway mission lasting a year even at that point, because I mean we're not supplying station like every day. We're supplying it, you know, every other month or so.
Yeah.
So if you can have a launch window every single month to go to the moon, then you can keep sending supplies over and over again.
Yeah, it's an extended family. Won't give away details. An extended family member of mine has a lake house up in pretty much the middle of nowhere in New Hampshire. But that's why it's beautiful. It's because it's in the middle of nowhere. There's no one around, no light pollution. But it's been there for several years, and it's every time we would go up, it's like you just bring something, and it's literally like, do we have room in the, like, okay, put in like a lazy boy, or, you know, put it in a microwave, or bring up toilet paper, or bring up, you know, tools, like, and it's kind of what I imagine is going to be like the Artemis or the entire moon program is, because every time you go there's a little more, and at first it was literally like the whole thing runs off literally like gas tanks. Now there's satellite internet, flat screen TV, there's, you know, and it's there's four-wheelers, there's jet skis, and now it's and every time you go up there's more, and you can stay longer and longer, and it's less like you're huffing it into the middle of nowhere, and it's more like, now you go up there and it's literally high speed Wi-Fi, watch satellite, you like movies, Netflix, like Apple TV. Now it's like, we have this really cool place, and now you get to enjoy the middle of nowhere because you don't feel like you're in the middle of nowhere. You can step outside and see like moose and like, you know, a trillion stars, and then you can also come back inside and sit on Instagram and vegetate and look at memes. So it's you enjoy it more. I feel like that's what it's going to be like with the moon, is like it's less like, holy shit, we're on the lunar surface, like, you know, if we literally it's like our body, everything's calculated down to like the ounce, and it's more it kind of loosens it up a little bit,
because it's
more comfortable.
Instead of just about like making it there, it's about doing things there. So it's like then, you know, once you can go there comfortably, and you can get onto the surface, and you can leave, and you can come back and keep doing this, that opens the door to having a permanent, you know, research base on the ground.
When are we doing that?
So that I mean I can't comment on like if they'll actually follow through with certain things and stuff, because everything is not going to happen until it does, kind of. There's reason, you know, to see like the value in that of like learning to live on the surface for an extended period. There was a Moon Resource Conference or whatever. I keep meaning to watch some of the talks from that, and the ULA CEO did one on that, about like how the moon is really like the place we should invest in, because being able to get there is is really important for being able to extend our reach. So on one of the latest manifest picture things that shows some of the stuff that's supposed to be coming out, it's not like official, it's kind of more like planning wise. But it was used to talk the topic of like how this is all going to work, and it shows, you know, like 2021, 2022, 2023, and at least public contract wise, there's 10 SLSs that have been bought.
Oh, damn.
So the funding for them has already been allocated, and Boeing, who has been manufacturing them, is still on contract. So the third one has metal cut for it already, but not finished, of course. The second one has metal cut formed in tanks, which you can pull up online, that need to be covered in foam and stuff, and then continue. But you can foresee, like, you can churn these things out faster the more you make them. So you end up with like once a year to twice a year to 3 times a year, maybe more, of flying these things and getting there. But there's the kind of interesting part is there's kind of a push-pull of like, I can only build a space station module so fast.
Yeah.
So not being able to fly as much is okay if you don't have value in going yet. So one of the things with it is SLS is upgradable. So it's made to be modular. So it has they're called block numbers. So there's block 1, which we're working on now, which will fly through 2024 basically. And block 1 is the basic version. It's basically meant to just fly crew. It has a decent amount of like extra margin though, because it is meant to fly heavy, super heavy payloads. So it has a little margin. So we throw a few small satellites on to go with it as like extra cargo. But there's the Block 1B, which is the upgraded version that has an upper stage that's sized much larger. So this is, you're talking 41 tons to the moon, basically. So that's where SLS and all the other competitors like fall away, basically. A lot of rockets get rated, and people look at the low Earth orbit, the tons number, which is a good grade of performance, but depending on your mission, that may not be as important.
And I'm guilty of that. I was always like, we got to orbit. Let's, it's a little bit more to the moon. I didn't realize just how much more fuel and I guess momentum, force, showing my true idiot here, to get to the moon. It's like, it's not the same. Throwing up, space station, what's that, 220 miles? Okay. Geosynchronous satellites, 36,000. I mean, how far is the moon?
I got a computer right here, so I might as well use it, I guess.
Yeah. I think the video that you sent me said that the moon is 1,000 times farther than the International Space Station. So it's going to be 220,000?
It's 238,000, basically 239,000 miles.
Yeah, so not comparable. It's apples and oranges.
Yeah.
Okay.
And the energy, the way things work, like with a rocket, they call it C3, which is like characteristic energy. So that's like your real, like the meat of the performance of how much, like if I burn this thing all the way to the end, how much energy can I get out of it? And getting out of the atmosphere is one thing, but once you get up, you have to do a lot with whatever mass that you have. So the two big performers in that right now are United Launch Alliance and eventually us, and kind of Blue Origin, but they have a slightly different mission trajectory. But like United Launch Alliance, they win most of the contracts for anything above low Earth orbit, which is all the more expensive things, which is why they're not going after the low Earth orbit contracts.
Yeah.
So they do the Mars rovers, they do most of the GPS satellites, and they use liquid hydrogen and oxygen, which is like that's the most bang for your buck, efficiency wise. So for every pound you can put up, you can get more energy out of it than you could with like kerosene or methane or anything else. So they use that, and we use that. We use a lot more. We're actually getting there's a cool time lapse online if you scroll through enough on the Kennedy YouTube or Twitter. It's our new hydrogen sphere being built. So it's a giant storage tank out at the launch pad, and they've been building it incredibly fast.
Yeah.
You know, the time lapse shows, you know, days are going by, and it's like, you know, like a basketball kind of, like all the different pieces going around.
Okay.
And it's like 1 million gallons of hydrogen.
Jesus.
And there's already one out there, so that tells you how much we actually use.
Yeah. Good Lord. Good Lord.
Yeah.
Yeah. So, as I always say with every guest, I can talk for hours and hours and hours, but you said you got stuff to do, so it's almost.
I can do maybe like 10 more minutes.
Okay, cool.
But just to kind of finish this out.
Oh yeah. Sorry.
Yeah, no problem. So the hydrogen, the cool thing about it is, like I said, it's really high energy. So you get like a really big advantage when you're trying to go far. So in going to the moon, you know, we're 41 tons translunar injection. You look at the next down, which is a Delta Heavy, and that's like, I think 10. And then you look at the next down from that, and it's the Falcon Heavy, which is like 6. So as a comparison too, like Delta Heavy and Falcon Heavy, they're like decently similar.
Yeah.
Falcon Heavy has way more thrust. It's like twice as powerful engine-wise, but it goes to show how much that efficiency, because one's a hydrogen rocket, one's a kerosene rocket, and how much that efficiency changes the game, kind of.
Yeah.
And when you're trying to do like super heavy payloads, you can fly them with our system instead of any of the others, because they can't do it. So that's like the real value in putting this extra money into something like this. There's, I mean, Starship, which will eventually come online, but it doesn't have, even with methane, the same performance efficiency. It's a lot better than what they currently have, C3 wise, but it's just not optimized for spaceflight. So it may dominate the low Earth orbit game, but we are for a very long time going to dominate the heavy lift exploration class of rocket. So like with like a Falcon Heavy, the ULA Vulcan that they're going to have, the Atlas, Blue Origin, a lot of them, when they're going to send like a gateway element, that's the only thing.
Okay.
So they're going to send this, you know, habitat module, and it's going to fly out and it's going to meet up with the gateway. With us, we can send a fully loaded Orion spacecraft and an element connected together.
Jesus.
And still have room to spare for, you know, small satellites, you know. So if you imagine like something about the size of a microwave or a PC case, we built 13 of those in a ring, and we just boop, 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 as we go by.
Yeah.
They're like for Artemis 1, our first flight, we have 13. They're from all over the world. There's like university ones. There's there's one from Japan that's going to land, and it's you know, it's microwave size, which I think it's like the weirdest thing ever, because it's a CubeSat mounted inside of another CubeSat. So one is a relay so that they can talk to each other.
Yeah.
But the small one is connected to a gigantic hobby grade rocket motor.
Why?
So it's this little weight thing, and it's going to let go of it, and then this huge rocket motor is going to slow it down.
Oh, okay.
From,
okay.
You know, 1,000 meters per second, which is like, let's get that in the old money.
That'd be 3.6 million meters an hour.
2,000 miles per hour, just about.
Jesus.
2,200 miles per hour. So it's going to kill almost 2,200 miles per hour speed.
Okay.
With this rocket engine. And once it's done, it's going to disconnect from that, and it's going to inflate this big Kevlar airbag.
Yeah.
And it's just going to slam the surface of the moon.
I've seen animations like that. Those are so badass. Yeah, it's coming down and then it's literally just like and it's just like this huge thing bounces and it's spinning. I mean, it's brilliant though. I mean, if you don't want to deal with, how much time and energy and engineering to put stuff in where it's some of the Mars ones where they come down and it's like the thing slows down and it's almost got like a retractable.
Oh, the crane.
Yeah. It's, again, I get it. When you go to Mars and the entire thing is in one shot, you kind of got to go balls to the wall. But you want to make it simpler and something that you can do a lot of when it's just to the moon. Just to the moon.
Yeah.
But just to the moon. It's like you said with like the CubeSats, like the shotgun approach. Like you want
So
yeah.
Again, I'm glad you mentioned that. I'm tying this back to earlier. So one of the things that we have too that makes like NASA a really great work environment is they do a lot of innovation type challenges where a lot of this never, you never see it or anything like that, but it goes on kind of under the surface and it's improvement things. So they'll have they'll give you $10,000 if you win to develop your idea. So the idea could be like, hey, I want to improve the material testing on this hardware and make it faster. I think we waste a lot of time on it. I have a method for doing it faster. Here it is. And then you propose it and you get approved to move to the next step. You present before like a bigger board, of people with a more legit presentation. And then once you've done that and they like it, then they'll give you the money and you go pursue it. So a lot of those come up and they range in all sorts of things. There's one about like how to cultivate food or bring and keep food, like is an MRE the best idea? Is there any current technology to grow things on the surface in a compact method? How do you feed people during a 60, 90-day mission? So a lot of those, they're just like, we want to see ideas, and then we want to connect people with those ideas with, the resources to investigate them. So one of those is a mission idea to land objects on the surface to study it. It is really, really in its infancy right now. They just the other day ended the first open call for it. So it's like a Reddit page with upvotes, basically. No lie. And it's only like the agency, that can open it and vote and comment and all sorts of things. And everyone, here's the challenge, here's idea, and you can upvote each one that you like. And then the voting closes. There's like a second session and they look at it and they go onward. And I ended up submitting one for it because, why not?
Yeah.
They're open to anyone.
Yeah.
Sometimes people throw out like a very not fully mature idea, and then you'll see in the comments like a bunch of people are working it out, how that might work. So for mine, shotgun approach. I really like the airbag technique of landing. Yeah. And just building something really rugged. So, you drop it, and it's like this orbital drop shock unit that hits the ground, and once it hits the ground, it's fine. Yeah. And it's there, and it's going to do its job. Yeah. So my concept was like you have a mothership, and the mothership has a rack, of like dozens, like 100 small robots mounted to it. Yeah. And they all have those little rocket motors and airbags, and they all go.
Just shoot them down.
Yeah.
Don't even need them all to survive. Yeah.
Yeah. So on top of that, you have this whole swarm. Rovers are kind of delicate. You got wheels. Yeah. Wheels can. So these are like there's videos of them online. They're called Hedgehog. It's developed by the Jet Propulsion Laboratory to go land on like asteroids and stuff, and it's literally a box. It's a cube with rubber feet on all the corners, and it has wheels inside. You can spin up the wheel, and it has like a disc brake inside. Yeah. You grab the wheel, and when the wheel stops spinning, the rest of the cube wants to spin, so it like throws itself.
Oh, okay. So it doesn't get stuck.
Yeah. So, but it can do this like in really small amounts, so it can like just go one rotate, and then it rotate the other way, and it can like have a direction that it wants to go.
Yeah.
And get. So my concept is like sending a lot of those to the surface, and then they can all do prospecting and stuff and fan out. And,
yeah.
I got to talk with the team who built them. Who he's like a pretty young dude, and he was like, yeah, we aren't currently funded to continue research, but we have the base level for when it needs to be taken off the shelf. We can use it, and I'm hoping that because it just ended like the first phase of the challenge, that I can win the proposal and then get them their funding, and we can go investigate this as a real Artemis mission.
Yes.
So you'd have all these cubes all landing, and in talking through the idea, because my area knowledge is here, the area knowledge is here. There's just overlap and stuff, and I'll kind of uncover this picture of what you can do. They're like you could have them all have like a seismometer, to listen and sense the ground. And all spread out like that, like you have on the map, like they're all over the place.
Yeah.
You can map the surface under the crust and determine the locations of resources by listening in all these different spots for when there's like a small meteorite that hits the surface.
Yeah.
So like a sound, and the sound propagates through the surface, and because they're all listening, and they know the time and where they are, they can then communicate back to each other and make a picture.
And make an image. Yeah, I was just thinking as you said that, put them all over the place, and then you could almost have like up on the mothership, you could just have like a kinetic strike vehicle.
Yeah.
And it just, not only that, but you don't have to go, well, how big was the meteor? Like you could know the exact weight and the exact force, and you could be like, this thing is hitting this hard, and we know it's propagating this way. You could literally be, it's like, now everyone go over here and listen, and man, sonar just light up the whole surface. There it is. That's where all our stuff is. That's where we should land. Yeah. Rob, exactly. You're gonna be the director of NASA, Rob.
No, I just it's just neat because you get to like there's no barrier to entry to those challenges.
Yeah.
Like you get a whole spectrum of like, well, that's not too great of an idea or whatever, but there's nothing stopping you from putting it out there. You know? So anybody can put something up. It can be as mature or not mature. One group was like, these are our robots.
Yeah.
We are making these right now.
Yeah.
And then there's like, this is an idea, like purely like, here's a diagram. I got nothing else.
Yeah. Yeah.
And then there's one where it's like kind of in the middle, where there is a robot. It's like this, but it's not made for this application necessarily, but it could be.
Yeah.
That's just like one of the cool things. And with the whole program direction, it's all about like go and stay.
Yeah.
So we got like nuclear reactors that are like theoretically going to be able to be deployed on the surface. Because solar panels, huge array.
Yeah.
Drop a nuke down there. That's little
tiny
right
thing
that powers everything.
And runs
Mars,
forever. Yeah.
You've already developed it.
Yeah. Yeah. Yeah, dude, you did a good job at I know you don't officially represent NASA, but you've completely switched my mind on all of this. Like, again, because of the lack of the online presence, someone like me goes like what is this? Oh, it costs so much. Oh, why are we going back to the moon? Blah blah blah. Everything you just explained, I mean, for all intents and purposes, it's almost like we never went to the moon. Like, what Kennedy say? Put a man on the moon and bring him back to Earth safely. That's it. We did other stuff up there, but like how you just broke it down over the last hour is you've converted me. I'm not that I'm by any means knowledgeable in this stuff, but you've just got me amped up for this. So dude, you need to act as their online presence.
Well, like I said, I always try and like if somebody's like, why does this cost so much? I don't like that. I'm be like, well, it's pretty. When you come down to it, it's cheaper.
Yeah.
Like, it doesn't feel cheaper. It
Yeah.
feels like it takes forever. Nothing's
Yeah.
ever happened, and it's the most expensive thing ever.
Yeah.
But that's perception,
Yeah.
and then
And
perception when it encounters like reality. You have it's hard to do stuff like this. But it's like there's a lot of tracks and they're all kind of converging on this like one thing, and that's like you will soon be able to live on another planetary body with current technology. Like it was like, yeah, you could do that. You could build a nuclear reactor and drop it somewhere, but now it's like, well, that is the nuclear reactor that they're building right now. There's like I think it's Motherboard or whatever, some YouTube channel. They have a video and like, this is it. This is the prototype for it. This is what they're working on. This is the production version.
Yeah, it's very simple to just, it's and not only that, it's like I said, there's no one hitting back against SpaceX. So it's like SpaceX said that it's it's all a bunch of money and it's not going to work, and we've already been to the moon. But the way you just described it, and I think you also said it perfectly, is like, not only is it better than what we did with the Apollo program, you can't even just compare it dollar for dollar and be like, look how much cheaper it is in the Apollo program. You have to then also be like, and look at what percentage of like the GDP Apollo got. Look at the blank check they got. So like, you're going at it with a fraction of what they had, and your costs, and you're still producing stuff at only a fraction of the costs. I mean, it's fraction. It's orders of magnitude better. It's just, to the layman, and that's, I think, stems back to the lack of online presence, the lack of the meme division, is you look at it and go, oh, we've already been to the moon. Why are we going back? It's going to cost how much? Blah, blah, blah. And I'm completely guilty of that, but you just did a fantastic job. I'm sold on it. Screw SpaceX. Yeah. I'm on board now.
Well, and funny thing is, all these other providers, you got SpaceX out there, ULA, they're gun ho for it, because they're like, people are going to need launches to do these small lander missions.
Contract them, yeah.
There's these land companies who developed these landers, over the past few years, and they're like, we're just trying to develop this technology. Now they're getting tapped. They're like, hey, Stanford University has an experiment that they need put on the surface.
Yeah.
They're willing to pay this much, and here's a grant from NASA to cover the rest of the costs.
Yeah. It's
like it's not a alone. It's not like SLS is going to carry the whole mission. It's not like Starship or Falcon Heavy or Vulcan or any of that's going to carry the whole mission. It's, you cannot get the mass up fast enough and the launches done and parts completed fast enough unless everyone is all in. So you got Russia building parts, you have ESA building our service module, the Orion spacecraft. You got the capsule on the front and the solar panels on the back. The service module is European, so it's built by Airbus, and it's sent over and then attached to an American capsule and then launched here.
Dude, this is exciting.
I know, right?
This is legitimately exciting. And the worst thing is I didn't know any of this. Maybe I just live under a rock, but yeah.
Well, it's not out there as much. It is, but you got to look for it.
Yeah. That's the thing is, but you can't depend on people to look for it. You got to have people that, you got to have it just out there and in your face.
Well, and that's the thing is, launches make news, but prepping for launches doesn't as much.
Yeah, well, because no one wants to hear it. It's like, show me when it's done. It's because how many past administrations have said, and we're going back to the moon. It's like, it's almost become like it's almost like a cliche. Like, oh, make sure you say that we're going back to the moon. Like,
but like, it's cool because that's what's happening. It's like literally like we are gonna go back to the moon, and it's gonna be a permanent, long-term presence. And you have, I'm trying to find this photo here.
Yeah.
all of them are shit quality.
No, you're fine. Dude. Yeah, it's.
But things are moving forward, and it's a slow crawl. It's a march. I really like the Blue Origin motto.
Yeah, yeah. Slow is smooth, smooth is fast.
Well, it's slowly forward ferociously.
Yeah. I listened to Space Barons, and it's basically the breakdown. It's a book, but it's like the breakdown between SpaceX and Blue Origin. And yeah, Jeff Bezos' whole thing is it's almost like a huge like cog. It's like it moves slowly, but it like demolishes everything in its path. But it's like a glacier. It's like it's only going to move an inch a year, but it's going to literally ground mountains to dust. It's
nothing will stop the momentum. Basically.
Yeah, it goes slow, but it's like it's going.
A quick pan. So this is our real core stage. This is going to take us, on our capsule back, in a couple years, basically. Not even a couple years, under a couple years, basically. But that's going to fire, in a few months, and kind of usher in a whole new age of, this whole Artemis program and new lunar exploration. So
hell yeah.
And it's there. It's in the test stand right now. They're working on it, getting it ready. There's a lot of wires and plugs to check and get hooked up. So slow and steady, you get there.
Slow is smooth, smooth is fast.
Exactly.
God damn.
Exactly. But it's great because the first Artemis mission on Orion and SLS, it's going to have a decent amount of outreach to it, and when that thing flies, it will be the news.
Oh yeah.
It will dominate the news cycle because that capsule will be there for a month going around the moon.
Yeah.
And as a part of it, it is covered in HD cameras.
Yeah.
So a really cool one out on the solar panel that does a selfie of it. It has a real purpose of inspecting the solar panels to make sure they're fine.
Yeah.
But also, it gives you a beautiful shot of the capsule and the moon behind it, basically.
Yeah.
And eventually the Earth behind it too.
Yeah. They better be utilizing that. They got that launch. They need to be blowing that thing up like the goddamn Super Bowl. Yeah. That has to be. Not just for people that are interested. They need to blow it up so much that you can't avoid it. It's like, what the hell is this thing? What's going on? That's what you got to do.
Yeah. Well, it will be the largest rocket ever to have launched, basically.
Jesus Christ.
So the Saturn V is slightly taller in the current configuration, but once it moves to the Block 1B, it will be the largest flying vehicle ever, basically.
Jesus.
It has 8.8 million pounds of thrust at takeoff.
What was Saturn? 7.5?
Yeah.
So, I didn't know that. I didn't know that it was going to be more. You've sold it. You've sold it. You've sold the game.
Well, that's what I'm supposed to do,
Well, you did a fantastic job.
Thanks.
Yo, Actually, no, I'll text you about that. Let's definitely do one after in the future because you're doing your launch tomorrow, right?
Yeah, I'll be flying this guy. I stuck Orion nose cone on top of it.
Hell yeah.
This one actually is going up with it. This goes on my mini SLS.
Hell yeah.
Yeah, the rockets. Right.
Pan it.
Right over there.
Yeah, you 3D printed that. Yeah. For everyone that's interested, that's what our previous episode was about. Yeah. I'm gonna link your channel in the top comment, and dude, thank you for doing it, Rob. It is.
Of course, I like talking to you. It's cool to get the excitement up,
Dude, hell yeah! And please, again, my podcast is your podcast. Please, you don't wait for me to ask you. Tell me, Tommy, I'm coming on and we're talking about this. Cool, great, got it, good. Don't wait for me, dude. Literally, if you want something, let's do it.
Yeah.
All right, Rob. Well, text me tomorrow. Let me know how your launches go.
Yeah, for sure, man.
All right, dog. All right, man. Peace.
Peace.